This is our light tactical helicopter mock-up. Right now, it specifically explores a configuration that could be applicable to a little bird replacement. It could be applicable to a armor reconnaissance helicopter replacement. As you look down the nose of the aircraft, you'll see the aircraft configured in for two different missions. This side of the aircraft is configured for a MH mission. The far side of the aircraft is configured for an AH mission. On the nose of the aircraft, you'll see a flare. We'll also be looking at integrating a retractable air-to-air refueling probe. On the far side of the nose, we'll be interested in integrating a conformal pod for a 25mm-ish, 20mm-ish gun. We'll do those trade-offs. Follow me around to the cockpit. Although early in our design concept, the cockpit has a couple of key functions that we look at. Number one, the controls are a little bit different and unique. We have a traditional side-on controller, which is our collective function, and then we also have a cycling stick that has yaw, pitch, and roll function on the stick. The yaw function is turning of the stick. The mock-up doesn't have pedals on it right now, but I would anticipate as we mature the design, you'll probably see pedals not to control our yaw, but as brakes and comp switch down below. We'll have a rich debate about how much information is actually necessary heads down versus heads up on the helmet. The seats are in a more of a reclined position. We're finding that if we set the pilots back a bit, it enhances crash worthiness because the weight is distributed over a longer area versus a single point on the seat. There's still some additional trades that we'll make with visibility. We want to continue our visibility, increasing our visibility outside the aircraft. If you look at the cabin area itself, this cabin is configured for 6 350-pound assaulters. So it's a 225, 250-pound soldier with the 100-pound of equipment that they're going to drag around the world with them. We'll look at trading off our cabin configuration with having seats that are back-to-back, which allow for easier access out the doors, easier opportunity for the weapons, and also to get out on a beam and do things that special operators do. We have a coaxial main rotor system. The stall area on a traditional helicopter drives speed, or limit speed, which is generally in the area of 180 knots maximum. In our case, we have a coaxial system. We have two counter-rotating sets of blades, both with a negative stall area, but we have two counter-lifting areas, which allow us to balance and really beat that stall question. If you look at our dynamic system, it's a 33-foot dynamic system, very similar to that of a little bird, and also a Kiowa Warrior size. So that operation down in the urban environment, in the buildings, with this very small profile, continues to be important. We also have the ability to lower our tip speeds down, which will drive down our acoustic signature significantly. So if you think of a high-speed aircraft, let's for a minute envision ourselves as an enemy with a rifle down in the urban environment. Imagine for a minute a OH-58 flying across at 90 knots, its maximum speed, maximum cruise speed, and the time it's exposed, and the cueing that you get early because you can hear it, versus this aircraft, twice its speed, with half the exposure, with 40% less acoustic signature. All kind of important that fits into that warfighting paradigm. Another key technology is reducing down our IR signature. If you look at the dimple on the aircraft, this is where our exhaust tanks are. The cool outside air goes into the engine. Air rather than exiting out of a small confined area, on the top of the tail cone, heading north, is a 4-inch by 5-foot long exit van. There's injectors in there that swirl the air when it comes out and mixes with our wash from our main rotors.